Hello everyone, this is Xiaofei from Microsoft Cognitive Service Research Group. Due to the need for social distance led by the COVID-19 pandemic, people and organizations have to rely on online conferencing tools to stay connected and work remotely. With the surge of online meetings, it has become more critical than ever to use speech enhancement technology to provide high-quality speech audio and live captioning under various noise conditions. However, most monaural speech enhancement models introduce processing artifacts and thus degrade the performance of ASR tasks. In this work, we propose a framework for optimizing speech enhancement models for both communication and transcription quality. The framework aims to build a speech enhancement model that achieves better ASR performance while retaining the same speech quality as conventional speech enhancement models did. Right figure shows the proposed multitask framework. The framework alternatively performs two steps named SE-step and ASR-step. In the SE-step, the model is trained with parallel data created by artificially mixing clean speech with noisy files as the conventional supervised SE training. For the ASR step, we use a realistic offline ASR model trained on a large amount of data based on the ASR loss. In both steps, only the SE network is updated, while the ASR model parameters remain unchanged. The training scheme allows us to leverage real noisy recordings which do not have the corresponding clean speech signals to optimize the SE network. At each training iteration, the update step to be used is randomly chosen. We refer to the probability of choosing the SE step as the SE step probability, which is a hyperparameter that can be tuned. Before performing the multitask training, the SE model parameters are pre-trained. We employ DCCRN as our front-end model because it achieved the best speech enhancement performance in our preliminary test, while we also provide the result using DCUNet to examine the generalization capability of the proposed framework. We evaluate our framework by using both real and synthetic data under various noisy conditions. Regarding the evaluation matrix, we use the water rate, PASC, STOI, SDR, and the PMOS scores. The experimental results show that applying the multitask training to the seed SE model consistently improved the water rate, and these water rate improvements were obtained with little speech enhancement quality degradation. For example, in the DCCRN experiments, our proposed framework improves the water rate by around 12% relatively for real recordings. Another thing I want to mention that we use different ASR systems for training and evaluation, which shows the generalization capability of the proposed framework. For this multitask training, we also conducted ablation studies by changing the backend ASR model, the training data for the ASR step, and the schedule of the two training steps. Some interesting observations can be found in this slide. Thanks for watching.